Hey guys, welcome back to part 2 of our NCEA Level 1 Tables, Equations and Graphs exam from 2020. In the previous episode, we took a look at question number 1, talking our way through it all, and we're going to do the same for this question here. Make sure you keep in touch for question number 3, which is coming up after this video, and also the question or part number 4, where we see how well we've answered the questions based on the marking schedule. So let's get straight into it. Okay, so question number 2, part A. On the axis below, sketch this graph. Let's just write out the graph so that first off, it's in my own handwriting so I can see it better. And number 2, I know exactly where my eyes need to go when I'm scanning across the paper. So we start off with y equals x squared plus 2x minus 8. Now, when we have a problem like this, we're going to split this up into some sets of brackets. So 2 sets of brackets. In the first bracket will be what multiplies together to get that first value. So we're going to get x and x. In the second part here and here, we're going to have 2 numbers that multiply to get negative 8, and also those numbers need to add to get positive 2. So let's write out the factors of negative 8. I might actually do it off to the side over here. Negative 8. Negative 8 is made up of negative 1 and 8, and we are just using integers at this stage. Negative 2 and 4, negative 4 and 2, and negative 8 and 1. No other integers are factors of negative 8. So now we're going to look for the pairing, so like a pair like that, negative 1 and 8, that add together to get positive 2. Well, negative 1 plus 8, that is 7. Negative 2 plus 4, that's 2. Negative 4 plus 2 is negative 2, and negative 8 plus 1 is negative 7. So which of those is positive 2? What's this one? 4 and negative 2. So our numbers that go in the brackets are negative 2 and 4. Now both of these are really handy formats for equations. The first one is really handy because we can just pop in zeros where these x's are, and that will give us our y-intercept. So if we put in 0 into x, then 0 squared is 0, so that goes to 0, and 2 times 0 is also 0, and we're left with y equals negative 8. So when x equals 0, so that is here, y is negative 8, which is down here. Pop that on the graph. That's our first point. Another point we have is comes from our set of brackets here, our factorized form. So to work out the roots of the equation, which is where it crosses the x-axis, all we need to do is say, let's let y equals 0. So this y here is going to equal 0. 0 equals x minus 2 times x plus 4. Now this is a statement asking, when is this true? When is this equal to 0? Well, we have a multiplication of 2 numbers. We know that when we multiply it by 0, we end up with 0. That means that either this is 0 or this is 0. Let's take a look at this one. X minus 2 is 0 when x is 2. And this one, x plus 4 is 0 when x equals negative 4. So our 2 values for when y is 0, that's at the x-axis, is x equals 2 and x equals negative 4. So we have 2 more points for our graph. Okay, the next part is to find out where the turning point is. A quadratic is a parabola, so it looks like this, or sometimes like this if it's a negative parabola. So we need a turning point where it goes up and then gets to the top and down, or when it goes down and gets to the bottom and then comes back up. That occurs in between these 2 roots because a parabola is symmetrical. So halfway between these 2 is this point. That's directly halfway in between. So somewhere on this line, negative 1 will be our turning point. To work out which one it is, we go back to our original equations and we pop in the number halfway between negative 4 and 2, which is negative 1. We can put it into this top equation. We get negative 1 squared plus 2 times negative 1 minus 8. Negative 1 squared is 1. 2 times negative 1 is minus 2. And then minus 8 from there. So we end up with 1 minus 2 is negative 1. And then minus 8 from that is negative 9. So we can plot that on our graph. That will be right there. Let's just double check by putting it into this equation. If x is negative 1, then we have negative 1 minus 2. Sorry, did I say negative 1? Yeah, negative 1. Negative 1 minus 2 is negative 3. So it's negative 3 multiplied by negative 1 plus 4 is 3, which is negative 9. Same answer that we got from up here. So two different ways of doing it. And there are many, many more. But now we have our fourth point. 1, 2, 3, 4 points. We're going to join all of those up with a nice smooth line. So there we go. There's our attempt at a parabola using the equation given above. Question part 2. Tui's in her school volleyball team. She's practicing hitting the ball over the net as shown in this diagram. The height of the top of the net, that's here, is 2.4 meters above the ground. The equation of the path is given by that equation, where x is the distance from the net, so x is that way, and negative x is that way, and h is the vertical distance above the ground. How much higher than the top of the net will the ball be as it passes over? So that's asking, what is this distance here? So all we need to do is take our equation, which is h equals, okay, so the net is at x equals 0. So all we need to do is put in 0 where these x's are. We end up with h equals the negative 0.2, that doesn't change. 0 plus 2 is 2, and 0 minus 8 is negative 8. Now we multiply these together because brackets in between brackets are multiplication symbols. So we have two negatives here, so our final number will be positive. 2 times 8 is 16, and then times that by 0.2 is 3.2, I think. H equals 3.2. I'll just double check that on the calculator. Is 3.2. Excellent. Okay, but the question asks, how much higher than the top of the net will it be? So we have 3.2 take away 2.4 is 0.8. It asked a question in English, so we replied in English. Tui is concerned that the opposition players will block her shots at the net, i.e. jump and stop her shot from coming over the net, as shown in the picture. The picture's blank, so it looks something like this. That's them jumping, and the ball gets blocked and then gets bounced backwards. How could altering the equation of this ball, of the path of the ball, have an effect on whether or not her shot is being blocked at the net? Provide at least two suggestions that are based on graphical reasons. So graphically means a graph. So there's two ways. We could either increase where this point is, so instead of being 0.8 meters above, we could just move or shift the line of the ball to something like this. So exact same equation, but the up and down just means we add a number on the end. So that's one option. Let's quickly write that down. So I've given a quick explanation graphically, starting with the word graphically, because I do want it graphically. The path of the ball could be shifted vertically. And we do this by adding a positive constant on the end of the equation. So we have h equals negative 2, blah, 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 and then I've added 1 meter to the equation, so it's now 1 meter higher. Another option would be, let's say that we hit the ball, but then we end up something like this. To change this, we just need to change the coefficient on the front of the equation. So in this case, to get it steeper like that, we need a larger number. In this case, it's negative, so a larger negative number. So like, for example, instead of 0.2, could change it to 0.4, 0.5. Just like that, with the coefficient of the equation, negative 0.2 could be changed to a larger negative number like 0.4 or 0.5, which means we get that steeper gradient. Okay, let's go on to question number C. Tane is practicing his volleyball skills by throwing the ball over the net. Tane is at a horizontal distance of 3.2 meters from the net, so this distance here is 3.2, and he hits it at a height, that's this height here, of 2.3, shown in the coordinates. The ball travels a perfect parabola shape that is reaching a maximum height of 4.8 meters when it's 1.8, so this here is 1.8, from the other side of the net. Find the equation of the path traveled by the volleyball as it leaves his hand and heads over the net, as shown in the diagram above, where x is the horizontal distance from the net. The x-axis will be at ground level and the h-axis will be in line with the net. Justify your answer with full and clear working. Now, if we think about a parabola, the parent parabola looks like this, and it has the equation x squared. Now, to shift this across, if we wanted to shift it to the right by 1.8 meters, so instead of the equation or the parabola being here, it's now shifted to here, we just minus 1.8 meters. So now we have our equation here. We also want to make it negative, so we're going to add a negative on the front. That brings us to here. And now we're going to shift it upwards by 4.8 meters, bringing us something like this. To shift upwards, we add 4.8 meters onto the end. So our equation is h equals negative something. We don't know what this is. We also need to make this wider. And these are just sketches that I gave up top. So I'm not sure how accurate they are, but either way, we don't know what the number is. So let's put in a value for some number that we're not sure of just yet. X minus 1.8 squared, oops, I forgot the square over there, plus 4.8. So now we just have to figure out what this k value is. To do that, we use some values or some points that we already know. We can't use these values here because we've already used those in our equation. So instead, we're going to use these details here, negative 3.2 and 2.3. The height is 2.3, so we can plug that in. 2.3 equals, and we're going to keep pretty much everything else the same. We're just going to change this x value to negative 3.2 minus 1.8 squared plus 4.8, keeping everything the same. 2.3 equals negative k. Doing a whole bunch of math now. What's that? That's negative 5 squared plus 4.8. Let's work out what negative 5 squared is. Negative 5 squared is 25, so we now have positive 25. Positive 25 multiplied by a negative k is negative 25k plus 4.8. Let's minus 4.8 from both sides. 2.3 take away 4.8 is negative 2.5 equals negative 25k. The 4.8 is gone because we minused it from both sides. And now we divide both sides by 25. Negative 2.5 divided by 25 divided by negative 25 equals k. 2.5 divided by 25, is that 10? 2.5, that sounds like a very big number. It must be 0.1. Divided by 25 is 0.1. 0.1 equals k. So our k value is 0.1, and our equation is h equals negative 0.1. I'm just reading off this line here. Negative 0.1 times x minus 1.8 squared plus 4.8. We'll box that. There's our final answer. Let's move on to the next part. Ruru joins Tane standing in the opposite side of the net. Tane sends the ball over the net towards him. The equation of the path traveled by the volleyball is given there. Lulu dives to reach the ball before it hits the ground but misses the ball. Using equations or graphs, find how far away from the net the ball will be when it first hit the ground. Okay, so it hit the ground when h is 0. So let's write all that out. H equals negative 0.25 x minus 2.1 squared plus 3.9. So the ground is at 0, is at 0, so we can put in 0 equals all of this stuff. Okay, now we just have to solve for x. Let's minus 3.9 from both sides to get rid of this 3.9. Let's divide both sides by negative 0.25 to get rid of this. 3.9 divided by 0.25 is at 15.6. Let's just double check that. 3.9 divided by 0.25, 15.6, cool, equals x minus 2.1 squared. Let's take the square root of both sides to get rid of this square. The square root of 15.6. Well, the square root of 16 is 4, so it'll be a bit less than that. Is it about 3.8-ish? The square root of 15.6 is 3.95. I was a little bit off there. Equals x minus 2.1. Let's add both sides. Let's add negative 2.1. Let's add 2.1 to both sides, giving us 3.95 plus 2.1 is 6.05 equals x. Yep, yep, that's right. So x is 6.05. So the question asked, how far away from the net will the ball first hit the ground? The ball will first hit the ground at 6.05 meters from net. 6.05 meters, is that within the boundary of the netball square? I'm not sure what the size of a netball field is. Netball field, is that what it's called? Netball boundaries, I don't know. Okay, let's also do it on a graph here. Now on this graph, it doesn't give us any scale, so we'll have to work that out ourselves. So we have that negative 2.25 is going to mess me up a little bit here. So how about this? How about we draw up a table, since this is tables, equations, and graphs. Let's draw up a table that has all of these values in it. So we'll have our x values and our height values. Now our x values will be distance from the net. We want the positive distance from the net, I think. So we start off with 0 and then we go up. We know we want to get to at least 6. So let's see if 6 is pretty close to where the ball touches the ground. And then for our heights, just like we did on a previous question, I think it was negative 0.25 multiplied by x minus 2.1 squared plus 3.9. We want to set this from 0 up to 10 is fine. We're going up to 6, but 0 up to 10 is just fine. So let's execute and we can see, yeah, that's pretty much 6.05 will be our landing point. So we're on the right track. These are all pretty close together. So yeah, let's just write all of this down here and then we'll transfer it over to the graph. Okay, so we've got our table. We'll take this over to the graph and then plot these points on this graph. Let's see, I might go every 3 is 1 meter. Every 3 lines. 1, 2, 3, 4, 5, and 6. And I don't think we need to go too much further. And then vertically, let's go with every, I don't know, well, we need to get up to 4. So if we go every 5, we get 1, 1, 2, 3, 4, 5, 2, 1, 2, 3, 4, 5, 3, 1, 2, 3, 4, 5, 4, 1, 2, 3, 4, 5. And we don't need to go any higher than that. Okay, so at 1, we had at 0, we've got 2.8. This will be 1, 2, 3, 4, and 5. So at 0, we've got 2.8. Let's just switch color, go back to our pink. 2.8 is 2, 4, 6, 8, right there. Next one is 3.6 at 1. 3.6. Next one is 3.9 at 3. 3.9 is here. Then we've got 3.7 at point. Minus that. Yeah, minus that. That's supposed to go here. 4 and 2. 3.9. Next one is 3 and 3.7. 3.7 is there. 4 is 3. 4, 3. 5 goes to 1.8. There's 2 is 1.8. And 6 is 0.1. And what was 7 is theoretically negative 2.1. Negative 2.1, which is way down here somewhere. Okay, let's join all of those up with a nice smooth line. And we can see that the intersection point is right here. All its ground at just above, or just past 6 meters. And that is the end of question 2, I believe. Now, just as a quick aside, I'm just going to quickly Google size of a netball court. That's it, a court. 30 meters long, holy moly. So it's 15 meters. 15 meters, the length is 15 meters, so it's really long. I had no idea it was that long. Okay, there we go. That is well within the measurements of, or the boundaries of the netball court. So, very surprising for me to learn that. I had no idea. It's very surprised that it's that big. But we've finished question 2. Let me know if I've made any mistakes throughout this question, and we'll find out in a couple of episodes time or a couple of videos time. I'll see you in the next video for question 3.